Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at a question from the IB Chemistry November 2019 paper, and it's a paper one, and it's an HL paper. But the content that is discussed in this question is applicable to both SL and HL students. So both categories of students must learn this topic. And the topic is the shape and orientation of atomic orbitals and how we represent them. So the way that we represent these shapes or where we do it is on an axis. So I'm sure all of you have seen this type of axes by now. You know, you have an x-axis, you have a y-axis. This is something that we have done in math for a very long time. And we use these axes to represent these atomic orbitals. And before we get into it, what really is an atomic orbital? Well, an atomic orbital is a region of space where there is a high probability of finding an electron. And that is what an atomic orbital is. And there are four different types of atomic orbitals. There are S, P, D, and F. And many of you might have already heard of them, but for the sake of this question and this video, we're only going to be taking a look at the shape and orientation of S and P on a plane, on a graph, and how they look like. So the S orbital is very simple. It is made up of only one orbital, right? The S atomic orbital, it's only made up of one orbital, right? And that is the orbital which looks like this. It's spherical. This is how it looks like. That is it. And it can fit up to a maximum of 2 electrons. So the 2 electrons in the S orbital, it can be found anywhere in this region over here, this shaded area. So this is the S orbital. And that's what they've asked us in this question, which represents the shape of an S atomic orbital, where we've already got our answer. It's A. But I'm also going to explain to you how the P orbital looks like, the P atomic orbital. Now, the P atomic orbital is made up of 3 orbitals. It's made up of 3 orbitals. The S orbital is only made up of 1, but the P orbital is made up of 3. So it's Px, Py, and Pz. And this X, Y, Z represents the orientation of the P orbitals on this graph over here, this graph that I've drawn. It represents. Now, X and Y you all know, but what is Z? Well, Z is this. This is the Z. I'm sure many of you not have seen this. In math, we only tend to use X and Y, but we're also using Z in this case. So the P orbitals are dumbbell shaped. So like I said, the S orbitals were circular, right? They were spherical. But the P orbitals are dumbbell shaped. They look like an 8 or a dumbbell. So they look something like this. The dumbbell. So the electron is most likely to be found in this region, in these regions over here, these shaded regions. So I'm going to draw it on this plane and hopefully you understand what I'm talking about. So let's draw the Px. Well, the Px lies on the x-axis as indicated by the name. So it's going to look something like this. There you go. That's the Px orbital. So the electron can lie anywhere in this region. Now, what about the Py orbital? The Py orbital, again, as indicated by the name, lies on the y orbital. Sorry, on the y-axis. So it looks something like this. And the electron can be found anywhere in this region. Now, the Pz orbital, again, lies on the z-axis. And it looks something like this. Now, I know it's a bit difficult to see it, but hopefully you can make out the Pz orbital that I've drawn. It's over here. So that is it. That is the shape and orientation of the S and P orbitals on a graph. Now, in this question, which represents the shape of an S atomic orbital? Well, we have already discovered that. The answer to that is A. S orbitals are spherical. P orbitals are dumbbell shaped, and there are 3 of them. It's a very bad drawing, but hopefully you understand the idea. Kind of looks like a flower. So What about these others? Why are the others wrong? Why are B and D wrong? Why are C wrong? In B, we can see an S orbital. Why is it wrong? Well, the thing is that even though there is an S orbital in B, this over here, this is the S orbital, the thing it represents over here, this is actually the formation of a sigma bond. The sigma bond is a head-on collision of two orbitals. When atoms covalently bond with each other, the head-on collision of two atomic orbitals, this is what it represents. It's representing a sigma bond, the head-on collision between a p orbital and an s orbital. So this is actually not representing an s atomic orbital specifically. It's representing a sigma bond. So that's why this is wrong. And for the exact same reason, even D is wrong, because it is representing the head-on collision between two p orbitals. It's a p orbital and this is a p orbital. So it's again representing a sigma bond, not the shape of an s atomic orbital. And C, for obvious reasons, C is not representing an s orbital, s atomic orbital. It is representing a p atomic orbital, because like I said, the p atomic orbitals are dumbbell shaped. And more specifically, it's representing the py atomic orbital, because py, this is in the y, this is oriented in the y-axis, right? If you draw the axes, y, x, so it's a py or a p orbital, whichever you prefer to call it. So that is it for this video. Hopefully I've managed to explain this concept well to you. Thank you so much for watching. If you have any more questions about this particular topic, please feel free to reach out to me on my messages and I'll be more than happy to help you. That's it for this video. Thank you so much. Take care of yourselves and I'll see you in another video with another question. Goodbye.